The never-ending search for the creation, storage, retrieval, and analysis of colossal volumes of data triggered the motivation behind the origin of big data testing. Testing such gigantic amount of data requires precision tools, remarkable frameworks, and brilliant strategies. Hello and welcome everyone to yet another tech enthusiastic video from Edureka. I am Ravi and today we'll be discussing about big data testing. So without wasting much time, let us quickly go through the agenda for today's discussion. Firstly, we shall understand the need for testing big data. Followed by that, we shall understand what exactly is big data testing and the strategies behind the big data testing, big data formats, and the big data testing environment. Once we are done with this, we shall understand the terminology behind the big data testing. Then we shall understand the tools used in big data testing, challenges faced in testing the big data, and finally we shall wind up the session with understanding the difference between big data testing and traditional testing. Now, let us quickly start with our first chapter. The first chapter is about learning why exactly we need to test the big data. Most of the users might end up with one question that asks why exactly we need to test the big data. You might have written the queries correct and your architecture might be just fine, yet there might be many possibilities for a failure. Let us assume a classic case of a drastic failure that occurred in a bank. The designers of the bank database wanted to create a phone application which could enable phone banking to the customers. So, the designers of the bank database named the customer name as CN, the customer bank location pin code as CL, customer ID as CID, and customer phone number as CP. Now, the bank wants to make key value pairs of customer ID, which is CI, and customer phone number, that is CP. In this scenario, the MapReduce algorithm gets messed up between the letters P and L, which is a keypad error or the typing error. Now, the customers won't be getting the OTP and the phone banking facilities. Just imagine this scenario in a real-time situation. Horrible, right? So to avoid such mistakes in real time, we prefer the big data testing. Now we shall understand what exactly is big data testing. So big data testing can be defined as a procedure that involves examining and validating the functionality of big data applications. The big data is a collection of a huge amount of data that traditional storage systems cannot handle. Testing such a huge amount of data would take some special tools, techniques, and terminologies which will be discussed in the later section of this tutorial. Followed by this, we shall understand the strategies behind testing the big data. Testing an application that handles terabytes of data would take the skill from a whole new level and out-of-the-box thinking. The core and the important test that a quality assurance team concentrates is based on three scenarios, namely batch data processing test, real-time data processing test, and lastly, the interactive data processing test. So what exactly is batch data processing test? The batch data processing test involves test procedures that run the data when the applications are in batch processing mode, where the application is processed using batch processing storage units such as HDFS. The batch data processing test involves test procedures that run the data when the application is in batch processing mode. In this, the application is processed using batch processing storage units such as HDFS. The batch processing test mainly involves running the application against faulty inputs, varying the volume of the data. Now, next comes is the real-time processing test. The real-time data processing test deals with the data when the application is in real-time data processing mode. The application is run using the real-time processing tools such as Spark. Real-time test involves application to be tested in the real-time environment and it is checked for stability. And the last one is interactive data processing test. The interactive data processing test integrates the real-time test protocols that interact with application as in a view of the real-life user. The interactive data processing mode uses interactive processing tools such as Hive SQL. Now moving ahead, we shall understand the different forms of big data. So there are three main forms of big data, which are structured format, semi-structured format, and unstructured format. Firstly, we shall understand what is the meaning of structured data. Any tabular data which is meaningfully organized under rows and columns with easy accessibility is known as structured data. It can be organized under named columns using different storage units such as an RDBMS. For example, any tabular data stored in an RDBMS. Now we shall understand what is semi-structured data. Semi-structured data lies perfectly between structured and unstructured data. It cannot be directly ingested into an RDBMS as it includes metadata, tags, and sometimes duplicate values. Data needs some operations to be applied on it before the data is ready to be ingested. For example, .csv format and .json format. Now lastly, we shall understand what exactly is unstructured data. Data that does not obey any kind of structure is known as unstructured data. Unlike the structured data, the unstructured data is difficult to store and retrieve. Most of the data generated by organizations is unstructured type of data. For example, image files, video files, and audio files. Now we shall understand the big data formats in a little detailed way, where we have the examples for structured, semi-structured, and unstructured. Firstly, we shall deal with the structured data. So the structured data is available from the sources like data warehouses, databases, ERP, and CRM. Now when we enter into semi-structured data, we find the sources from .csv files, .xml files, .json files. And finally, we come into the unstructured data, and the sources for the unstructured data are audio files, video files, and image files. Now we shall move ahead and understand the big data testing environment. Owning a perfect environment for testing big data applications is very crucial. The basic requirements for big data testing are as follows. Firstly, space for storing, processing, and validating terabytes of data should be available. Then, the cluster and its respective nodes should be responsive. And lastly, the data processing resources such as a powerful CPU should be available. Now with this, let us enter the big data testing. So the general approach in big data testing involves three stages. Firstly, the data ingestion stage. In the data ingestion stage, the data is first loaded from the source to the big data system using extracting tools. The storage might be HDFS, MongoDB, or any other similar storage. Then the loaded data is cross-checked for errors and missing values. The basic example for data ingesting tools is Talend. Followed by the data ingestion phase, we have data processing phase. In this stage, the key value pairs for the data get generated. Later, the MapReduce logic is applied onto the nodes and checked if the algorithm works fine or not. A data validation process takes place where we make sure that the output generated is as expected. And finally, the last stage is about the validation of the output. At this stage, the output generated is ready to be migrated from the data warehouse. Here, the transformation logic is checked, the data integrity is verified, and the key value pairs at the location where the data needs to be dumped is validated for accuracy. So these are the three phases in which the big data is tested. So with this, let us enter the next chapter where we will deal with the different categories in which a big data application can be tested. Firstly, unit testing. Unit testing in big data is completely similar to any other unit testing in similar applications. The complete big data application is divided into segments, and each segment is rigorously tested with multiple possibilities for an expected outcome. If any segment fails, then that particular segment is sent back to the development stage for improvements. Now, after unit testing, we enter functional testing. Functional testing can be otherwise called as different phases in testing the big data application. The big data application is designated to deal with huge blocks of data. Such a huge volume and variety of data is often prone to bring data issues such as bad data, duplicate values, metadata, missing values, and whatnot. This is exactly why the pioneers in testing the big data designed the procedure for functional testing of big data. The different phases in which the big data is tested are as follows. Firstly, the validation phase. Data validation phase deals with the business logic and the layers of big data application. The data is collected from the source and it is run against the business use case. Data collected is checked for accuracy and movement through the different layers of the application. At this stage, the big data is tested with aggregation and filtering mechanisms. The data undergoes end-to-end validation and transformation logic based on business rules. The next stage is data integrity phase. Data is checked for completeness with referential integrity validation. Data constraints and duplication is verified against error conditions. Boundary testing recognizes schema limits for each layer in integrity phase. The next phase is data ingestion phase. This is a very important phase where the data gets ingested into the Hadoop ecosystem. The ability of the application to connect with different data modules is checked here. The data is replayed with messaging systems and loss of data is monitored. The main motto of this phase is to achieve the following qualities. Firstly, fault tolerance, then continuous data availability, and lastly, stable connection with a variety of data streams. Followed by data ingestion phase, we have data processing phase. The data processing phase carefully examines and executes the business logic. The business rules are cross-validated. The MapReduce logic is validated at every stage. Data is processed from end to end. The application is checked for exceptions and they get perfectly handled. Followed by the data processing phase, we have the data storage phase. The data storage phase concentrates on the following parameters, which are the read and write timeouts, continuous data availability, load balancing, and finally the query performance analysis. After all these stages, we have one final stage which is called the report generation phase. It is the final stage in functional testing and it deals with the following: data validation for measures and dimensions, real-time reporting, data drill up and data drill down mechanisms, and lastly, the business reports and chats. So this was the functional testing. Now let's move ahead and understand non-functional testing. The non-functional testing phase takes care about three major dimensions and characteristics of big data, which are the volume, velocity, and variety of big data. There are 5 stages involved in non-functional testing, which are data quality monitoring, infrastructure, data security, data performance, and failover testing mechanism. Firstly, we shall understand data quality monitoring. Data quality monitoring checks for erroneous data, records, and messages. Data quality monitoring makes sure that the following parameters about the data are available, which are the data accuracy, data precision, data timeliness, data consistency, data profiling. Now, the next stage is the infrastructure. The infrastructure makes sure that there is a continuous service availability in both external big data processing applications and internal big data processing applications. Infrastructure also takes care about the data replication factor, data backup, and data restore point. Followed by the infrastructure, we have the data security. Data security is called to be the most important aspect of the big data application. Data security stage protects the sensitive data. It manages user authentication and checks user role-based authorization. Data security also takes care about the data encryption and masking of personal information. Followed by data security, we have data performance. Data performance evaluates every single component. It evaluates maximum data processing speed, evaluates maximum data capacity size, checks the message transfer speed and response time, calculates the number of operations performed per unit time, engages parallel job monitoring, and finally performs read, write, and update operations on real-time databases. And lastly, we have failover test mechanism. Failover test mechanism ensures seamless data processing while switching to neighboring data nodes. It creates data recovery points and parallelly, it will be ready for any unexpected calamities. Failover test mechanism will be ready to replay the data using multiple offsets. It enables dynamic clustering. With this, let us move ahead into the next type of testing, which is based on the performance testing. Performance testing highly concentrates on the performance delivered by all the components in the big data system. Performance testing includes the following categories. Firstly, the data collection phase, data ingestion phase, data processing phase, and finally, component testing phase. Firstly, we shall understand what is data collecting phase. In this stage, the big data system is validated based on its speed and capacity to grasp the data within the given frame of time. Data can be collected from different sources such as RDBMS, databases, data warehouses, and many more. The next stage deals with the data ingestion. Here, the application is tested and validated based on its space and capacity to load the collected data from the source to the destination, which might be HDFS, MongoDB, Cassandra, or many other similar storage units. Followed by the second stage, the third stage is data processing stage. Here, the application is tested based on the MapReduce logic written. The logic is run against every single node in the cluster and the processing speeds are validated. The queries to be executed are expected to perform with high speeds and low data latency. And finally, we have the component testing. This stage is related to the component performance. Each component in the system should be highly available and connected. The component backup should be online when any node fails. High capacity data exchange should be smoothly supported. Now with this, let us move ahead and understand the performing testing approach. The performance testing approach can be understood through the following flow diagram. Firstly, the procedure begins by establishing a big data cluster and running the application. Later, the big data developer designs the workload required to run the test. Then in the next stage, we involve the clients into the test and take their feedback. After that, execute the application with data and analyze the results. And now, if we find the application to be performing with optimum stability, then the process is finished. Else, we applied the required modification and retest the application. So this is the performance testing approach. Now, followed by this, we shall understand the parameters involved in performance testing. So the parameters involved in performance testing are data storage. Data storage takes note of the orientation in which the data gets stored in the system. Followed by that, we have commit logs, which marks the limits for committing logs. Followed by that, we have the concurrency, which checks the number of threads allocated for the read and write process. And next to the concurrency, we have caching. Caching includes dedicated row cache and key cache. And finally, we have timeouts. The timeouts set the timeouts for the application, which are related to the connection and queries, etc. Followed by the performance testing, we have architecture testing. Architecture testing concentrates on establishing a stable Hadoop architecture. The Hadoop architecture of big data processing application plays a key role in achieving smooth operations. Poorly designed architecture leads to chaos, which might be performance degradation, node failure, high data latency, and may require high maintenance. So these were the chaos which may show up if you have a poor architecture in your big data application. Followed by this, we shall understand the big data testing tools. So the big data testing tools are majorly classified into 4 categories. Firstly, big data ingestion tools, then big data processing tools. Followed by that, we have the big data storage tools, and lastly, we have big data migration tools. Now we shall look at the examples based on each one of them. Firstly, the big data ingestion tools. Zookeeper, Kafka, and Sqoop are the best examples for data ingestion. Next, we have data processing, and the popular tools used in big data processing are MapReduce, Hive, and Apache Pig. The next kind of tools are the data storage tools. The most famous examples for data storage are Amazon S3 and HDFS. Finally, we have the data migration tools, and the popular examples for data migration are Talon and CloveDX. Now with this, we shall move ahead and understand the challenges faced in big data testing. So the key challenges faced in big data testing are: big data testing is highly complicated and the process requires highly skilled official. Automated big data testing procedures are predefined and they are not suited for unexpected errors. Virtual machine latency creates latency in tests and managing multimedia is a big hassle. Followed by that, the volume of the data is one major challenge for big data testing. The testing environment and automation should be developed for different platforms. Each component is from a different technology as it requires isolated testing. No single tool can perform end-to-end testing. Followed by that, high degree of scripting is required for designing test cases. And finally, customized solutions are required to increase performance and test in critical areas. So with this, we shall move ahead into the last topic, which deals with the difference between traditional testing and big data testing. So the first difference is the big data testing supports all type of data testing, whereas the traditional testing supports only structured testing. The next difference between the both is big data testing requires research and development, whereas in traditional data testing, we don't require research and development. The third difference is the data size is unlimited in big data testing, whereas the data size is limited in traditional testing. Followed by the third difference, we shall enter the fourth difference, which says big data testing requires special environment, but whereas the traditional testing doesn't require any kind of special environment. So now we shall enter into the last difference, which says only highly skilled and qualified candidates can perform big data testing, but when it comes to traditional testing, the basic operations knowledge is enough to run the tests. So with this, we come to an end of this session. If you have any queries related to this session, then please feel free to write them down in the comment section below. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!